we're going to talk regarding the medicine promise of Enos technology for cancer detection. Unfortunately, due to the time difference, I'm not available to talk online. That is why I'm going to record my talk for you. But I wish that after this nice webinar, we can contact through the email to each other, or if we can talk through the Skype, that will be the good chance to have the later collaboration. So on, first of all, I should thank the organizer, the Journal of Cancer and Treatment, and let us see the first agenda of my talk. Initially, I will talk about the smell and its role and when really it will use in our daily life. Then we will see about the body breath and smell and diagnostic disease which is possible through the detecting the different smell. And then we will see one of the Enos which I designed. Actually, these are 2-3 designs that I have done regarding the Enos, and we will analyze the structure of the Enos for this job, and then we will have the conclusion. Okay, first of all, I should tell you there is the big potential for this task, and if I want to give you some brief detail about myself, I have done my PhD about other localization, movable one on the robots, is that OLS system, and then I have done some limited job. As you will see, I have some 10 copyrights, 2 patents, 3 books, and generally I'm engineer. And maybe between most of the participants in this webinar that they are working on the medicine, I'm not much more familiar about your area. But as the person who work in the uh, biodesign and bioengineering design, I can give you some feedback. Maybe we can find the um, further collaboration and work together. Okay, let us see. First of all, see what is small and where it can be, where is smell and where it can be used. You know, smell, we know it as olfaction, and it will be one of our 5 senses. In the sense that around us, every day we are engaged with this type of signal, which can analyze by us and give us different output. For example, if we see this odor and sensing the smell was very critical from the long back. Suppose if you see the cartoons or some movies which is related to the mind, there is the boy that always have the cage. They call it canary boy. Why? Because there was one canary inside this cage, and if the canary died, it will say that carbon monoxide and carbon dioxide from the mine was more, and all people should leave the mine. Otherwise, it will be the blast. Even nowadays, also for the firemen, we have the problem of the leak of the gas in the building. And somehow people call these as the second tragedy after the fire in any building, because we have the leak of the gas and then it will be the chance for the blast there. So on, this smell even can work in the security job, suppose in the airport or in the train station. Nowadays, you will see that there are some dogs that they are going to check that if your luggage, you have any drugs or any bomb or something like that inside, and then that dogs can act as the detector of the bomb. Then so on, even we have in most of the countries any rate of the death due to the leak of the gas, methane gas, and because there is the leak for that and people are not aware for that. And then because they don't know where is the exactly location of this leakage of the gas, then we have the rate of the death for the people. then we can understand that even nowadays, knowing and having this type of signal can save the people of save the human lives. Even for the avalanche and even in earthquake also, we can have some system that detect the smell or detect the breath of the people and say that there is the body inside all these, I don't know, avalanche or in earthquake or no, and then it can save and help the people in the rescue missions. But if we want to compare, there is one nice analysis that I found through one of the web page. It said that dogs, even they are great, but even we have some other creature that can work, maybe better. For example, African elephant, they have the 1,948 organs, or rats, they have 1,207 organs, or even pigs, they have the 796 organs, which is, even if we want to compare with the human, somehow these organs is more. Let us see this analysis which compare with the human. It says that deers are 9 times better than human, dogs are 20 times, bear are 2,100 times better than human for smelling. Then we will see that inside the creator or inside the nature even, we have the good use and good uh, application for having the smell. As you know, for the smell, because most of you are much more familiar than me with the biology, we have the one part in the nervous system which can takes the signal that we call it organs, and then these organs will send the signal to our brain, and in our brain we have the some receptor that they can translate this signal for our brain, and then we can distinguish between these different smell. Have this picture in your mind. Again, we will come back and analyze this one more, the type of then, if I want to compare the human and animal nose, we can understand that even spider monkey have the rate of the 80 regarding the odorants, or mouse have 13 regarding compared to human, and even pig, they are much more better um, odorant system than people and human. Even we have some record that several hundred years ago, some village doctor in rural China, they could diagnostic some disease through the breath of the people and smelling the people, especially for the diabetes. They could find out maybe this disease between the breath of the people. And even some hospital nowadays use some battery of the blood test and laboratory analysis to make some same diagnostic. But about this, again, they need to have the sniff for the smell of the breath of the people. What we can say that there is the nice application from the nature that maybe they are doing for the finding the mates, they are doing to finding the foods, they are doing to do, we can say, their daily lives, and to rescuing the people lives, to even nowadays we want more focus on finding the disease and do some diagnostic regarding the different disease based on the smell of the people. Even the record in the some review shows that there are some dogs that they can find some type of skin cancer, or now it's proof that the dogs can help to detect for the Parkinson disease and even Alzheimer disease and even sleeping sickness, and all of them. People understand that with the signal of the smell, we can have some way to understand, or maybe we can have sometimes pre-diagnostic for some different disease. Even if you remember in the time of the COVID, which that was very horrible time, in that time also there was some research which people have done to do the detection of the COVID through the breath of the people, and they take the smell signal from people. But really, where this idea it's related to long back. As I read some history, I understand that Alexander Graham Bell in 1914, that was his idea and his word, that he said that if you ever measure the smell, and then you have done the real job. These are the sentences that he told us, that can you tell whether one smell is just twice as strong or another one? Can you measure the difference between them? And if you find a new science, then measure the smell. It means that these smell signal have lots of interest from long back between the scientists and between the people. And it means that there was some evidence for them and they found some way that they can detect it. So on, if we want to compare and have the different, maybe we can say some classification for the aroma that people have. We can have that we have 8 different aroma. For example, earthy aromas, floral aromas, fruity aromas, spicy, fishy, sweet, medicinal, and chemical aromas. These are the 8 area or 8 different aromas which till today they could put the stamp of that, means that they found the difference between others. And you know that maybe there are some aroma that human cannot understand, and something like mixture of them that animals can understand. That is why they could detect it better. Even we know that they have the more organs that humans, but maybe something like that or some training like mixture of them help them to do the better classification and precise one than human. So on, if we just want to focus on the importance of smell in the medicine, I can tell you that there are 9 aspects that we can do. One is that we can think for the smell as the diagnostic indicator, which can serve as the indicator for numerous health condition, and it can help us to find the infection, neurological disorder, metabolic condition, and also it can find some type of the cancer, which we will talk later more about them. As the monitoring health status also, it can help us to recognize the different order, which is closely linked to some overall health status, and change the smell sensitivity or perception can signal underlying the health issue, and help us for doing the better evaluation and monitoring later. Safety and warning also, it can be one application, as I tell you, for the leaks, for the spoiled food, for hazardous chemical, or some assessment like nutritional assessment for the food preference and appetite and so on, for psychological and emotional well-being, for example, for uh, emotion, they say that there are some smells or some odor from the human's body. There are some proof for that, that people say. For the quality of the life and social interaction, for neurological treatment monitoring and environmental and exposure, these are the 9 areas that we can work on the smell and medicine. But really, a smell plays a very role in the healthcare, and it can be as the one of the indicator for humans' body and maybe lifestyle as we talk about it. But let us see, for example, which gas is currently found out in the human breath. We have some O2 gas, we have some CO2, we have some N2, H 2O, and also trace gases we have, which, for example, O2 is in the inhale, I mean the oxygen, it's in the inhale from the atmosphere and using the reception system. CO2 will be produced as the waste product of the cellular metabolism. N2 will be the major components of the air, and mostly it will be in our exhaust part. HO2 will be the moisture in the breaths which we have, and trace gases, it could be includes the organ, methane, hydrogen, VOCs, and so on. These gas currently we understand that we have, but still there are some VOCs which we can talk about it. By the VOC, we can say that up to 3,000 different VOC type, I mean, volatile organic components are detected, which can be a composition of them also can be shown the some metabolic uh, behavior of the human body. For example, you will see for the diabetes, we have the acetyl methanol isopropan VOC, or for the lung cancer, we have some aldehydes toluene. For example, some asthma, we have the nitric oxide and some ethane VOCs, and even for the kidney disease, we have the ammonia and isopropan uh, smell from the bodies and human body. This is show us that the smell have exactly some signal, and there is the relation between the smell and breath of the people. And from one way and from the other way, we have the different diseases that we can do the diagnostic regarding the percentage of any of these VOCs. Suppose some diseases are declared that they have some associated VOCs. As I tell you, diabetes are have the acetones VOCs there. Liver disease, they have the ammonia. Kidney stones in the urea. Lung infection, we have the isopropan, ethanol. Lung cancer, for example, we have the alkanes, benzene, and methane and ethane. They are for the cystic fibrous. As you will see, we have the different VOC from one part, and some disease and some condition of the disease which can be detected and used for the further analysis. So on, soon we will have something like a breath biopsy, which it can just by the breath of the people can detect the different diagnostic and can be used in different application and treatment. As the history for the second part, if we want to see, maybe this idea or the first spark can be from the Hippocrates in about 400 BCE. Then he said the sweet breaths of the diabetic people. And if we want to have more detail about the history of that, is the chart that I made for you. You will see that after Hippocrates in BCE, in 1784, we have the Lavoisier and Laplace that they are demonstrate and working the reception system uh, for the oxygen. Then in mid of the 180, about the noted of the diabetics often they emit spreads, and then we have some efforts in 1874 which can be isolated the ethanol from the breath samples, contributing an understanding of the breath consumption. Then we have some work till 1999, which they could get the gas chromatography system over the 3,000 of the components they could detect and classify from the human. Even till now, we have some attempt from year 2000, which comes with the word of the Enos that we will go to talk about this word. Then what we understand that from the smell, which can be detected before by different methods like real human or some dogs. Nowadays, we shift to one concept that we call it enos. Then, what is enos? Enos, in the sense, is nothing but replicate the olfactory system of the human. As we talk, we understand that through the number of the organ we have limitation. Then we are searching for the method or for the way that can replace the weakness of the olfactory system of the human and make it more powerful. How we can do? Very simple. We can change the part which we have in the olfactory system with some electronic part. That is why we call this system enos. Let us see how it will come. But before that, you will see that nowadays we have lots of application for the enos, from safety, from agriculture, from indoor outdoor of the HVC. We have industrial application and very different and various application which we can have by the enos. And recently we again jump to the medical and especially for different disease, something like cancer. How we can do this replacement is simple. In human olfactory system, we have the part that we call it receptor. This receptor we can change with the sensor. Then we have olfactory bulb, which the job of that is that sending the signal to our brain and then remove the noisy data and give the good data for us. Then I can use the processing signal and denoise system and filtering system, all of them here. And then for the brain olfactory cortex, I need some part that can classify and train before. Then now I can use some pattern recognition, AI systems, and so on, which can classify my signal. Then from the VOC, I can have sensor, process signal, pattern recognition, and then reach the identification of my VOC system. It's not bad to know that from 1920, this word of the enos interest lots of the researcher, and they are working in different countries, and even till now there are lots of people that they are trying to develop more and make the new enos in different application. Maybe from the alcohol test that police we have done, we have the application product from them, till now that we are trying to merge it with different disease problem. So let us see again how will be the block diagram of my enos. As we tell you, we have the aroma, we have VOCs, we have breaths of the people. Then after that, I need some method to extract that. Because we are working with the human breaths, then no need to extract. We have an inhale and exhale of the people. Then directly we can come through these steps. We can come to the sensors array. Then from these sensors array, because they are working in the digital form, then the analog data first should convert to the digital and then should save in processor part and do some pre-processing steps. Some noisy data should remove, and then through the data should get some feature and some important points, and then we can pass them to some classifier and then understand the VOC part. Something like this we can have. But for each of them, we have different section which we can take. As I tell you, for this sampling, if we want to suppose work for the any other VOCs, we need to extract the aroma. But for human, we don't need. Then we can miss these steps and directly go for the sensor array. For the sensor array, we have different type of the gas sensors. We have MQ, we have TGS gas sensors that they are sensitive to the different level of the gas. Even there is one main problem for them that they have some drift output, they have some long response, selectivity of them are less, and also they have some effective environmental effect like humidity and temperature. But still, we have some good gas sensors that can be used and help us. Especially for this type of gas sensors, MQ and TGS groups are more in demand, means that MOX type, because they can help us to have the more selectivity. And also, the next point is that the price of them, they are not much more high. But there are some challenges which I will tell you later. We have different type of sensors, as I tell you, but these MOX type are better. We can work on the optical method, electrochemical one, catalytic one, but these semiconductors are more demand and they are using in most of the INOs as their research record shows. Suppose these metal oxide are the part that already I told. Between them, as you will see, there is the list, for example, MQ or TGS1, which I bring here for you. They can detect the various type of the gas with different level. In the VOCs level or gas level, with the sensor, we have one scale that we call it ppm or parts per million. This ppm will be dynamic between the different type of the gas sensors, but we have the range that any of them can detect and sense. The next part will be the sampling and processing part, which they are doing the feature extraction, prediction, and classification. And then later we have the decision making part. For this part, we can use different methods like PCA, artificial neural network one, LDA, PLSR, and SVM, which they are more in demand and they are working and do the classification job for us and after taking the feature one. Then what we will have, we can have some flow chart like this. We can tell the people to do the breath and then take the turning the sensors on, take the samples and then send it to the converter to the digital one. After convert to the digital one, we can remove the noise, and then after taking the noise, we can classify the data and then declare the name of the VOC. It can be the full chart which we have. But as you will see, the aim is to increase the nose of the human. Maybe now you will say, well, oh, then Enos is very difficult. I can show you now some design which I have done long back, and they are working. For example, this is my first design that I have done in 2000, I think, 10 or 11. As you will see, I'm use the NQ sensors, just 4 sensor, 3 sensor I use, and then NI DAC card, which help us to take the different signature from the gas, especially alcohol gas, which we are working. This you can even see the result on the YouTube, because that time there was not much more description about INOS. Then there is one video that I put, what is INOS, and then we show the response of the gas. You can have the look to the response of this gas, which it's going to some level, and after that it will reach some steady state one. Later we have done different analysis based on this response. For example, I developed 2 different model for the gas sensor, which is published, and you can, if you're interested, you can read it. But there are the nice distinguish between the different level of air, alcohol, and other gas which we could do with this simple INOS. After that, I found that I should make the better INOS than the pipe side. I make it better, then I put some fresh air for that, some purging job I have done to have better and accurate result, and then results become much more better, as you will see here. Then we work on the quality of the some onions and foods and vegetables, even a smell of them, and it's published. And then we find the different difference between them. Then, as the one of the latest one, after this concept of the Arduino come to picture, we make one INOS system with three TGS sensors, 2600, 2601, and 2610, and then make everything compact in the form of a small processor, and make some models also for the gas sensors. The total setup was something like this, and we could get the signal of the peoples and also breaths of the people. Then, as you will see, there are the application of INOS in the medicines for early disease detection, for monitoring treatment, and disease classification, which we can find with the help of different VOCs. Some specific medical application also we have, which people reported based on, suppose respiratory disease, infection disease, and cancer detection, especially for early certain types of cancer like lungs and breast, which is much more applicable regarding the INOS. Also, there are some more disease which like the diabetes, and also level of the diabetes, class of the diabetes that can be easily done with the help of INOS is one of the major applications. To conclude, we can see that we have now two concepts. One is human nose, which can work with the limited number of the receptors and power, and on the other side we have the INOS, which even is very powerful but and sensitive, but there are some challenge for that which we will talk. And even there are some case studies that people have done for the lung cancer, for some harmful bacteria, for COPD symptom, for bumped others, other detection, environmental monitoring for the INOS part. This is the potential application of the INOS for the diagnostic of the disease which I bring here. You can read it even later. It's about the surgical application, food safety, and different area which it can help us, and so on. Even as I tell you, we have good advantage for the INOS, some like rapid diagnostic, high sensitivity, remote monitoring, and potential for the personalized medicine. But there is some challenge and disadvantage like calibration, standardization issue, cost consideration, and limited application of scopes that we are going and trying to develop day by day to remove this challenge. So on the calibration and sensor selectivity and validation and critical and clinical utility, I can say these are the main aspects that we can say we have for the INOS to enter it to the medicine area, especially for some disease. As you know, taking the sample by the patient is not simple, and it needs the clinical person like you that help us as the engineer, and then we can have the good collaboration later to develop these INOs more than more. As the future work and outlook, I can see that these INOs will make the good revolutionize healthcare and all for diagnostic and even pre-diagnostic method, and will be used more and more later in the medicine application, especially for diseases like cancer and other human disease. This INOS will be the future diagnostic system, which will be maybe faster, maybe the use of that will be easier, and also it's not like taking the blood test, and even the cost of doing the test will be much more cheaper than other blood tests. Somehow, now we don't think that INOS as the best test, but we know it as the pre-test, which can even do the classification very fast, and maybe the result even will be faster than other laboratory tests. So on, that was my talk. if you want to read about more other and the word of the gas leak, you can read one of my books. This is actually my second book, which we wrote it in 2019. It's about this gas sensor. I bring some this talk from different reference for you. I wish that you enjoy the talk from other colleagues in this webinar, and if you have any question, please send me through the email. I will be happy to have the collaboration with you on further work. Thank you so much. Once again, I should thank Professor Paolo and also Journal of Cancer Metastasis and Treatment for having such nice events. Wish you all the best and enjoy the learning from this